Hello, my wonderful students. You're welcome to class today. My name is Mr. Olukorede. I want to welcome those that are just seeing me for the first time. You're especially welcome to the class. So here we do solve problems on mathematics. If you have any problem in your mathematics, you can always bring the problem to this problem. Now, today we want to look at questions that modular arithmetic and mensuration. Okay, so I want you to sit back and let's do one or two things, and don't forget get your writing materials ready, and also don't forget to invite your friends. Let them know the class is about starting. All right, so as you are joining the class, ensure you say hi, greet the whole class, and ensure you also tap the like button. So those of you that have not subscribed to this channel, ensure you do that, okay, so that you'll be notified anytime we are on here. All right, so thank you very much. So this is the first question we are going to start with for today. Okay, so I want to believe we have a good number of you in the class before we commence the class. So once you join the class, say hi. So greet the class. All right, show me that you're welcome to class. Grace, you're welcome to class. Adewi Eniola, you're welcome to class. All right, so let's inform others that the class is about starting. All right, okay. This is Layo, you're welcome to class. All right, now let's look at the first question we have here on the modular arithmetic. Now the question express this in mode 7. Don't forget, whenever I want to write any number in a particular mode, it must be less than the mode, the number mode. Okay, so now that means the highest number we're supposed to have here should be what? Should be 6. All right, it must not be up to the mode. All right, so how do we go about this? Because this is a very big number, 10 raised to the power of 3. So let's look at it. So how do we go about that? Okay, so to do this, the first thing is I just pay attention to the base here, which is 3. So I find a way of writing this such that it's going to have a remainder of 1. Right? So now this is what I'm saying. Now just raise this one to the power of, when you write 3 raised to the power of 1, you have that to be 1. Okay? And also 3 raised to the power of 2 gives you a 9. All right, so if you are writing that in mode 7, what's it going to give you? That's going to be 2, because the same thing as 7 times 1 plus 2 in mode 7. So that means 3 raised to the power of 2, which is 9, is the same thing as what? As 2. Okay, so the next one is 3 raised to the power of 3. And that gives you 27. Okay, so 27. All right, so 27. Now this is going to be 7 times 4. Okay, no, 7 times 3. Now 7 times 3, that's 21. Okay, so we have a remainder of 6. Okay, so that means we have 6 here. All right, so now so that's 6. The next one is 3 raised to the power of 4. Okay, so now let's look at it. What do we have? So that's going to be now just look at this. This one is the same thing as 27 here. So you can simply multiply this by, because now I'm increasing this power by 1. It's the same thing as saying multiplying 3 raised to the power of 3 by 3 to have 3 raised to the power of 4. So that will give me 6 times 3. make the work easier for me. So now when you multiply this, what do you have? Now you have 18. So, and the 18 in mode 7, that is 7 times what? Times 2, that's 14. Remain what? 4. Okay, so that means the answer is 4. All right. So now let's move down to the next one. We have 3 raised to the power of 5. Okay, so we have this, which is also the same thing as 3 raised to the power of 4. So now we are increasing it, we are multiplying both sides by what? By 3. So when you multiply this by 3, you have this. Multiply this by 3. Okay, so we have 4 times 3. So what do you have? You have 12. 12 can be written as 7 times 1 plus what? Plus 5. That means we have 5. Get that? Okay, so and the next thing, you see, I can increase this. Okay, so that's going to be what? That's 3 raised to the power of 3 raised to the power of 6. 3 raised to the power of 6 is the same thing as 3, 5 times 3, right? Oh, sorry, I'm multiplying both sides by 3, right? Right? Oh, sorry, I'm multiplying both sides by 3, right? So I have 3. So since we have, so we have times 1. Okay, so when you multiply this by 3, you have 3 is for 7. Multiply this 1 by 3, you have 3. So, and that is 3. Okay, so now let us look at one more. So we have 3 raised to the power of what? 3 raised to the power of 8. Now it means I'm multiplying both sides. So I have 3 times 3. So 3 times 3 is what? 3 times 3, that gives me 9. And 9 can be written as what? 9 can be written as 7 times 1 plus 2. So that means we have 2. Okay. All right. So don't forget, my objective is I want to get an expression for 3 raised to the power of 10. So why didn't I do it this way? I will write it as 3 raised to the power of 8 times 3 raised to the power of 2 equals to. Now we have this. We have an expression here. What? 2 times 3 raised to the power of 2. So now what did I do here now? I multiply both sides. Both sides. This one, I multiply it by 3 raised to the power of 2. And this, I multiply this by 3 raised to the power of 2. Okay, so now when you do that, now this one is going to give you 3 raised to the power of 8 plus 2. All right. So now this one is 2 times 3 raised to the power of 2. I think we have gotten an expression for that before. And that is the same thing as 2. Can you see that now? So the same that 3 raised to the power of 2 is 2. We have it times 2 in mode 7. Okay. So we now have 3 raised to the power of 10 equals to 4 in mode 7. So, and this is going to be the answer to the problem. All right. So can you see that now? So that's how to solve this problem. All right. So is there any question based on what I've done here? So if you have any reservation based on what I've done, okay. So can you drop that in the comment section before I move down to the next thing, right? Okay. All right. Okay. So I hope there's no question, no observation based on what I did here. Okay. So that's that. Now let's move down to another question. Okay, so now let's look at the next question. Now find the last digit of 7 raised to the power of 27. So I hope every one of you are hearing me. All right. Okay, I hope you can hear me. Okay. So now let's move down to the question. Find the last digit of 7 raised to the power of 27. So how do you solve this problem? Now, just like we did in the previous question, so we pay attention to 7. So we write 7. What we want to do now is just to find all the last digits of any number that ends with 7. Okay, so we want to find the last digit. So that's what we're going to do. So now let's look at it. So we start by having all the digits. So you start by saying 1 raised to the power of, say 7 raised to the power of 1. So that is 7. Okay, so last digit of 2, that gives you 9. All right, so because you have 49. So 49, last digit of 49, we have 9. Okay, so the next one is 7 raised to the power of 3. Okay, now since this is going to be a big number, so I can just say, okay, I'm multiplying both sides by 7. So that is 7 times 9. And that gives you 63. You get that now? So you can see this is 7 raised to the power of 2. It's the same thing as 9. All right, so just multiply both sides by 7. So this by 7, you have this. This by 7, you have this. So that means the last digit is what? 3. You have 3. Okay, so you may not need to stress yourself of getting 49 times 7 again. All right, so now let's look at the next one. So let's multiply both sides so that we have 7 raised to the power of 4. That gives us what? That is 7 times 3. Okay, because we are multiplying both sides by 3. So what do you have for this one? So you have what? 21. So we have what? 1. Okay, so that's 1. All right, so now let's look at another one. So we have 7 raised to the power of 5. Okay, so now that means I'm multiplying both sides by 7. So when you multiply this one by 7, you have this. Multiply this by 7, you have 7. So now can you see now that we now have a circle of 7, 9, 3, 1. So we have started another series, 7. So the next one we are going to have is going to be 9. All right, because I'll be multiplying both sides by 7. So I'll have 49. So I will have 9 as the last digit. Okay, so and so on. So now I can get the circle. So the circle is 7, 9, 3, 1. So we have circle of 7, 9, 3. Okay, so now can you see it? So now the length of this circle now, what's the length? The length is 4. We have 1, 2, 3, 4. So length is 4. Length of the circle is what? Is 4. So that means that we take this to be in mode 4. All right. So what are we doing with that mode? So now you come here, the power we have here, now express it in mode 4. Okay, so now we have 25. Express 25 in mode 4. Mode 4. So what is going to be the answer to that? All right, so when you divide 4 by 25, so that's 4 times 6. Okay, that's 24. Remainder 1. Okay, so mode 4. So that means we have 1 mode 4. Okay, so now one of these digits is the last digit for this. And we can see 1, so we pick the first one. So therefore 7 is the last is the last digits. The last digit of 7 raised to power. So that is the answer to the problem. So I hope you all understand that. Okay, so any question, any reservation based on what we just did together? Okay. Oh, the board is low. Okay. All right. So that is the answer to that. So can we move down to another question? All right. So let's take this. All okay. Mensuration. The bucket is 12 centimeter in diameter. So from here to here is 12 centimeter. So now in diameter, so D, okay, I think the network is misbehaving. Okay, so all right, so that is the answer to the first part of the question. All right, so now the question I'll go further saying that we should find the total surface area of the bucket if the two ends are close. So I want to believe you can hear me. Are we back? Yes, because the network was bad initially. All right. Okay, so let's continue with the second part of the question. So all right, so the question says find the total surface area of the bucket if the two ends are closed. Now, don't forget, the bucket looks like this. The bucket looks like this. Okay, so, and if you are calculating the total surface area while the two ends are closed, so that means you are going to find the area of the upper part, area of the lower part, and the area of the curved surface. And so that's what we're going to do now. So now the first thing we are going to do here now is that let's find the area of the curved surface. Okay, so now let's do that. So what's the formula now to calculate the curved surface? So we have area of curved surface, curved surface, that gives us area of curved surface of the bigger cone. All right, so area of curved surface, that is pi r minus area of what do we have now? So that is this should be capital letter. R is L is pi r L. Okay, so that is what we are going to do now. So let us find because we can factor out pi. So when you factor out pi, you have RL minus RL. Okay, so now let us keep our formula here. We have the area. So it's going to be pi RL minus R. So this is the formula we're using. So now we need to get the slant length. L is the slant length. This capital letter L is for the bigger slant length, and the small letter is for the smaller cone. All right, so now let's do that. So don't forget, we have to complete this. To get that, let's complete this. So complete it, bring it down. Bring it down to this. Okay, we want to get the slant length here. So now here, we already know this place. Down, let's bring down the triangle here. We have this. Okay, so now we have x, and no, this is 24. Okay, now the longer side is 24, right? So and this smaller one is what? It is what? It is 14. Okay, so now don't forget this is 3.5. Why this is 6? So we can make use of Pythagoras theorem now to get this side here. All right, so can we do that now? So now we have let's look at the bigger one. So now this side, let's keep this. Now this side is 24. Now this is 16. All right, so we want to get this side. So we are going to be making use of Pythagoras theorem. We have x squared equals to, now you had the squares of the two sides, that's going to be 6 squared plus 24 squared. Okay, so and then we have x squared equals to 36 plus, now what's the square of 24? So we have 24 squared is 5 0.76. All right. So now we have x squared equals to, now let's add that and find the square root. So we have 36 plus 576. So what do you have? We have 612. And you find the square roots. So when you find the square roots, we have 24 points. So the slant length x is for the bigger one. So we have 24.7. Okay. So now let us look for the second one. All right. For the second one, the triangle looks like this. Okay, this is 3.5 and the height here is 14. So that means we have y, which is the hypotenuse. We have y squared equals to 14 squared plus 3.5 squared. Okay, so now let us add the two together. 14 squared, okay, plus 3.5 squared. So when you do that, you have 208.25. So you take square root of both sides. So when you do that, what do you have? So now this one gives me y equals to 14.4. Okay, so that's what we have. So we have the slant length. So this is our capital letter L, and this one is the small letter L. So we can now incorporate that into this formula and get the area. Okay, so let's do that now. So we have big L to be 24.3, okay, 1.7, and small L to be what? 14.4. Okay, so now let's incorporate into this formula. We have A equals to pi. Now R is what? The bigger R, that is 6. We have 6 times the L. I've gotten that. That is what? 24.7. Okay, so now minus. Now the smaller radius, that is what? That is 3.5. 3.5 times. Now we use that to multiply L here. That's 14.4. 14.4. So now that gives you pi. Let's multiply this. We have 6 times 24.7. So when you multiply that, you have 148.2 minus 3.5 times 14.4. So what do you have? 50.2.4. All right, so we have this as 22.7. Now let's subtract that. So what do we have when we subtract? Okay, so you have 97.8. Okay, so we have A equals to, so and let's multiply the two together. So we multiply that with pi. So when you do that, what do you have? You have 307.25 in centimeters squared. All right, so now the curved surface area. So the curved surface area is this. So curved surface area is 307.25 centimeters square. All right, so now, but the question is asking for the total surface area. So that means we are going to find the area of the upper circular sectional area and the bottom. So now let's look at it. Now the first one, we have the upper one, which is the bigger circle. So that is area of circle one. That's circle one. The up one. So that is pi r square. Pi r square. Okay. All right. So area of circle two. Okay. Cross sectional area, the bottom. That is what pi r square. So this one is for the smaller one, for the bigger one. So the total surface area now let's add this and this together, then we add it to this. Okay, so you know what we're going to do now. All right, so we have so area of the circle now is two circles. So we have area of the two circles Now that gives us what? Pi r square plus pi r square. Okay, so I can factor out this. So I can have pi. All right, let me factor that out. R is what? That's the bigger one. That is what? That's 6 square. Minus the smaller one, that's 3.5. 3.5 square. Okay, so that gives you what? 22/7 times. Now let us plus, sorry. So now let us add together. That's 36 plus 3.5 square. So when you do that, what do you have? You have 448.25. Okay. Can we multiply that with the pi? So times pi. So times pi. So when you multiply that with pi, you have 151.58 centimeters square. So this is the addition of the two circles. All right. So now the question is asking for the total now. So to get the total, so we add this and this together. So when you add that, so what do we have as our final answer? So the final answer now is going to be the addition of this and this. So let's add 307.25 plus 151.58. So our final answer now, the total surface area now is going to give us 458.83 centimeters square. So this is the answer to the problem. All right, so I hope you understand that. So any question based on that, any observation based on what we just did now? Okay. Okay, but is the board clearer now? Okay. All right. Very sorry for that. I guess it's the network. So the board was not clear initially. So I hope we all get the explanation. Right. So what we did now is we find the total surface area of the bucket. when the bucket is closed. So now the first thing we did was to calculate the curved surface area, and then we have the answer to be 307.25 centimeters square. Okay, so and the next thing is to